we might be given a questions, and we have several formula for magnetic field here. Okay, now if you observe, whenever you are given a question under long straight wire, you make use of this first formula. Then while the second one there, that's for center of what? A coil of number of what? Turns, that is n turns. If you are given the number of turns in a coil, okay, now you make use of this. Now for this, if you observe the, why this one is for center of a coil, we have two center of a coil, and this one is for what? N turns. Then why this center of a coil is also what? Of n turns. But this, sorry, this is just for center of a coil of a straight wire. Hello, please pay attention. Now for this one deal with what? With length. Why this one deal with radius? If you observe something, if you compare this one and this one, they both deal with what? With length, is it not? Hello. If you compare this one and this one, they both deal with what? With length. But the difference there is that for this one there is no number of what? Terms, but this one is carrying number of what? Terms. Why if you compare these two as well, okay, and the two, they are almost the same as well, is it not? But this one add nothing to, this one deal with what? With radius. And this one that deal with radius, this one carries what? Number of what? Terms. But this one has nothing to do with what? With terms. Are you getting me? So whenever you are given a question, it will be specified in the question. Now we have a question here. We are told that a 30 centimeter long solenoid, something that is long, that should be what? The length. Is it not? It should be the what? The length. We are told that a 30 centimeter long solenoid with an head coil has a total of what? 600 turns. Are you getting me? So here we are giving our length. What's our length? 30 what? Centimeter. What do you convert to what? To meter. It's stating as 30 over what? 100. We give us what? 0. What? 0.3 meter. So this time we're giving our number of turns n to be what? 600 what? Turns. And we're told that in a layer in such a manner that the current in it is moving in the same what? Direction in all of the layers. So we are asked to compute what? That very current. So we are looking for I, which is our current. And in the question, we're given our magnetic field to be what? 0.1 Tesla. So our B was going to be 0.1 what? Tesla. All right. Now this time around, if you observe, we are given length, okay, and the deal formula that deal with length is this and this, is it not? And we are giving number of turns. Is this one, is it carrying number of turns? Which one is carrying number of turns? Is the last one. Are you getting me? So that means this is the right formula to what? To use. Okay, and not only that, this one is for what? For solenoid, is it not? All right, so for solenoid, we have B equals to, we have U naught Ni, then over what? L. Now this your unit of Li is just like your E naught, okay, which is permittivity of free space. Now under magnetic field, please pay attention. Hello. Under magnetic field, you already know that normally your force of attraction is K, Q1, Q2 over what? R squared. But in terms of magnetic field, okay, we use F, that is magnetic force, equals to, that is K, here become what? M1 and what? M2. Are you following? Then over what? R squared. Then where our K is equals to 1 over 4 pi, then U naught. Are you following? In place of what? E naught, you use what? U naught. So from there it become F equals to, what's our K here? 1 over what? 4 pi U naught times what? M1 M2 over what? R square. We give us F equals to M1 then M2 then over what? 4 pi U naught then R square. So this time around, you can see that here we make use of poles. When it comes to magnetism, we use north and what? South pole. Are you getting me? But if it's your normal electrostatics, okay, we use what? Charge, which is Q1 and what? Q1 and what? Q2. Are you following? And in that one, make use of what? E naught. If it's your normal electricity now, it become F equals to Q1 Q2 over 4 pi SLN naught R square. Are you getting me? So in place of SLN naught, we don't use this. We use the what? U naught. Okay, and this one, your SLN naught, this one also has its constant value. So U naught is equals to, it become 4 pi, then times 10 raised to power minus 7 is Henry per meter. Henry per what? Henry per what? Then why your E naught? Our E naught is equal to 8.854 times 10 raised to power minus 12 colon square per Newton meter square. You can see the difference between the two. So this one we use what? 4 pi. It will be given to you in the what? In the question. Is that clear? But if it's not given to you, it's very easy. It's 4 pi times 10 to the minus 7 Henry per what? Per meter. All right. Coming back to this place. What are we asked to look for? We are looking for what? I, which is our current, isn't it? So from here, what is our B? So we have 0.1 equals to, you know, there is what? 4 pi times 10 raised to power minus 7. Are you following? Then times what number of terms? What number of terms? That is 600. Then we are looking for what? I. Then all over. What's length? 0.3. So we have 0.1 equals to multiply this. Pi is sitting as 3.142. So we have 4 times 3.142 times 10 raised to power minus 7, then times 600. So what do you have? 0.5408 times 10 raised to power what? Times 10 raised to power what? Minus 4i. The all over 0.3. What do you do from there? What do you do? So if we cross multiply, we have 0.5408 times 10 raised to power minus 4i equals to 0.3 times what? 0.1. So from there, so we have it as 7.5408 times 10 raised to power minus 4i, then equals to 0.3 times 0.1. 0.0 what? 3. So what do you do? They divide both sides by this, right? So we have I equals to 0.03 divided by 7.5408 times 10 raised to power minus 4. So I will be equals to, so divide 0.03 divided by 7.5408 exponential minus 4. So what do we have? 39.784. So current is measured in what? Current is measured in what? Ampere. So that's for that. So you can copy that. Any question, please? Determine the magnetic field in air 1 centimeter from a wire. That should be what? Length. Is it not? So we are giving our length. So what is the length? 1 what? Centimeter. Convert to what? Meter. That 1 over what? 100. 0.01 meter. Are you following? So we are told that carries a current of what? 2 ampere. So that's number 1 question. We're giving our current I to be what? 2 ampere. What are we looking for? Magnetic field. Magnetic field, that is what? B. All right, so this time around, look at, we're giving length and we're giving I. And between these formulas I gave to you, which one deal with length? The first and the last one, right? But this one deal with number of terms. Were we giving number of terms? Is there number of terms here? At least our U naught is constant. Pi is what? Constant. So you can get your, our length was given, right? And our what? Our length was given and current was also what? Given. So we can make use of this first one, right? So from there, our U naught is equal to 4 pi times 10 raised to power minus 7 Henry per what? Meter. So from there, don't forget, pi is also constant, which is what? 3.142. So we have B equals to, then we have U naught I over what? 2 pi L, isn't it? So from there, what are you not? 4 pi times 10 raised to power minus 7, right? Then times what's our current? Our current is what? 2. All over 2 pi. Then times what? What's length? What's length? 0.01. So pi can cancel our pi, right? So our b will be equals to 4 times 10 to the power minus 7 times 2 over 2 times what? 0.01. Are you following? So multiply the numerator. Multiply the numerator. So our b there will be equals to 8 times 10 raised to the power minus 7 over 2 times 0.01. What do we have? 0.02. So if you divide, if you divide, what do we have? 8 exponential minus 7 divided by 0.02. We have what? 4 times 10 raised to the power minus 5. Minus 5 what? Tesla. So number 2 question. We were told, compute the what? Magnetic field. We are still looking for what? Magnetic field. That's what? B. Then of a coil with 800 what? Turns. So here we are giving number of turns, N, to be what? 800 turns. Then of radius 50 centimeter. Here we are not giving radius, right? So what's our radius? 50 centimeter. That is 50 over what? 100. 0.5 meter. Then we are told that if a current of what? 3 ampere flows through the what? The coil. We are getting our current. What's our current? 3 ampere. Alright, don't forget U naught is constant, which is what? 4 pi times 10 raised to the power minus 7 Henry per what? Meter. Hope you are getting used to this now. So from there, we are looking for B. Now these are the formulas I gave to you. And don't forget, this one deal with radius, is it not? And these are the only 2 formulas that deal with what? Radius. And this one deal with number of turns. Is there number of turns here? So which one can I use? I can make use of this, right? So RB is equals to U naught Ni over what? 2R. So from there, B will be equals to what is U naught? 4 pi times 10 raised to the power minus 7. Then times what's N? 800. Times what's current? 3 ampere. Over 2 times what's radius? 0.5. So B will be equal to multiply the numerator. 4 times 3.142 times 10 raised to the power minus 7 times 800 times 3. So we are going to have what? 3.01632 times 10 raised to the power minus 3. All over 2 times 0.1. 0.5, sorry. That's 1, right? So our B will be equals to, so if you divide with this, what are we going to have? We have 3.01632 times 10 to the power minus 3 Tesla. Is it not? It's stating our B equals to 0.003016 Tesla. All right. So all the workings are clear. All the workings are clear. All right. So you can copy that.